training from no need to train from scratch, and limitations are struggles with messy handwriting and limited customization and fine-tuning capabilities. Now in this, they are comparing easy OCR model with HMM and RNN. As you can see, the accuracy is slightly higher compared to the both models, and precision also 83 to 89% of easy OCR model, and which is slightly higher than HMM and RNN. Recoil is also pretty good. F1 score is also higher than the other two models. And it's the conclusion and future scope. Easy OCR is a robust pre-trained model for basic handwritten recognition, suitable for rapid prototyping and application in multilingual environments. Future work is we should customize training integration with language models for error correction to enhance its capabilities. And that's it. If you have any Q&A, I'll answer.
Namal, on your camera.
Yes, sir. Okay, sir.
Because who is presenting, we should know, no? On your camera.
Just a minute, sir. Yes, sir.
Okay. Here, this noise removal, how is related to your work, and what technology we are using for noise removal?
We are using easy OCR model, which has easy OCR model, which has high accuracy and precision compared to other models like CNN, RNN, and HMM. It is used for mainly to recognize handwritten text.
By using CNN or RNN, we are doing that noise removal.
Yes, sir. CNN, RNN through
What
CNN
is
and
RNN?
RNN.
What is RNN?
Recurrent neural network, sir.
What is the difference between CNN and RNN?
CNN will visualize the text, sir. Like if any text is present, it visualizes the text, and RNN it maps the text, and it maps the text and constructs a word.
Okay. What is binarization? What is the use of that?
Binarization means converting image into binary form through in zeros and ones. It is useful for it converts the image in binary format, which is easily accessible.
Already we are using that grayscale conversion. No? So this is also
Yes,
for conversion.
yes, sir. Both are necessary, sir. Grayscale is for black and white, and binarization is for converting image into binary numbers, which is easy for input.
Okay, Madam. Good afternoon, Madam Kala ma'am.
Good afternoon, sir. Yes. Currently, you have done survey regarding handwritten recognition, right?
Yeah, ma'am.
Okay. Have you come across with any of the data sets?
Yes, ma'am. Like IAM dataset,
IAM
MNSet.
Which language you are focusing on? Only on English language?
Yeah, I'm mainly focusing on English language, ma'am.
I think you have to enlarge your language because multilingual is in trend now.
Oh, okay, ma'am.
Okay. And then what about what is the role of natural language processing in this one?
Like tokenization and
Yes.
removing stop words, stemming lemmatization,
Okay.
etc., etc.
In RNN, which language you are, which model you are going to focus on?
I'm not sure, ma'am.
Okay, your area is good. Please do
Yeah.
more deep knowledge. Try to acquire more deep knowledge about it. Okay.
Yeah.
Okay. Thank you. All the best.
Thank you.
That's all from my side, sir.
Okay, okay, ma'am.
Okay.
Okay, my next participant.
Okay. Okay, sir. Thank you, sir.
Okay, thank you, Mohammed. Thank you.
Yeah, ma'am.
Thank you, Harshad. Now I invite M. Rutvik to present the paper holding ID 135 from Gayatri Vidya Parishad College of Engineering.
Good afternoon, ma'am. Hello. Am I audible?
Yes,
Hello.
yes, audible.
Okay. Good afternoon, ma'am. Good afternoon, sir. So this is Ritwik, working as assistant professor in Gayatri Vidya Parishad College of Engineering. So I'll be presenting a paper on mainly regarding the crop viability. So it is regarding the crop viability. Okay. Main idea is regarding the crop viability. This is the paper. Perhaps this is the abstract idea regarding the completeness of the complete paper regarding the crop viability, particularly in the agriculture sector. So basically, this is one of the newborn idea in the agriculture sector. This is just a brief idea or the introduction regarding the main theme of drought-prone areas, regarding the drought-prone zones in making the agriculture in a viable manner. So, and aligning with the BCI interface, this is also one of the major key themes that suggests that this the sector that is growing, the crop that is growing, that viable crop that is growing in the drought-prone areas will be mapped to the human brain, so that the agriculture pattern or the path that is grown in the agriculture sector will be mapped with the human being sectors, so they can be aligned with together. So we can have the good sort of design like Zomato or Swiggy, like products in the agriculture sector. So that is the major key theme of my project. That is the prediction of crop viability in drought-prone zones using BCI. So coming to the abstract, crop viability is one of the major key sectors, mainly in the sectors like when there are certain incidents regarding the climate viability, so it will reflect the viability zones in the agriculture sector. So this paper reflects an intelligent system which is going to have the prediction of the crop growth under drought conditions, and we are going to enhance it with the BCI interface. So this BCI interface is going to act like how crop is growing and how human beings are consuming. So these two are mapped together so that the crop growth and the viability of the crop can be aligned with the human being cultivation or the motivation. So these two are the combined sectors that can be mapped with the help of BCI interface. So this proposed agriculture, mainly I am going to present the main abstract. Nothing but we have designed the complete model with the basic abstract data set. So we have generated the abstract data set, and accordingly we have done this particular theme is concerned. So mainly the proposed idea is that we have the remote sensing based technology in the agriculture sector, and we will be mapping with the BCI interface so that the consumption and the production, these two are mapped together, so that we can have the crop viability in the drought-prone zones, which are mainly happening in the recent times. The farmers are suffering a lot with the help of these sectors. So mainly the model that I have developed with this help of this crop viability, this can be mapped with the LSTM and convolution neural network. So I have trained the model with the convolution neural network and the yes, sir? Hello. I have trained the model with the convolution neural network and the LSTM so that they can be mapped together. And we have got some around 90% of accuracy along with this particular sector is concerned, particular drought is concerned. So coming to the major introduction, the major thing is that agriculture is the major foundation for all the security and the food health, mainly regarding the health zone is concerned. So production of the crop in the drought-prone areas is being one of the key challenges for all the farmers. And when the crop production in the drought-prone zones are aligned with the consumption of the food as far as the food-prone areas are concerned, this is one of the major innovative technology that comes over in the agriculture sector. Mainly with the help of AI, with the help of BCI interface, we can have the complete connection over the production and the consumption. These two can be mapped together. and whatever might be the insufficient production that happens in the agriculture sector, that can be recovered with the help of this complete eradication of the BCI interface, so that we can have the generative production, generative cultivation as well in the agriculture sector, so that production and cultivation can be mapped together. The complete production that mapped with the cultivation. So this is the complete idea of the project. And along with that, we'll be mapping with the completeness of the complete layers. The complete methodology is like this. We have the data collection layer, which consists of the IoT sensors. So this is already available in the agriculture sector, the basic thing. So we are going to do, what we are going to do is that we are going to map it with the help of PCI interface, so that production and the cultivation both are mapped together, and we can have the good consumption of the food according to the circumstances. And we have trained this model with the help of IoT sensors and basic interfaces with the help of deep learning neural networks with the help of BCI interface. And we are having the processing, pre-processing and other mechanisms that happens in the deep learning. We are doing all the pre-processing mechanisms that happens in the machine learning. And the entire cultivation is done according to the circumstances. And we can have the cognitive feedback as well from the customers. And we can generate all the product circumstances according to the consumer point of view or the ideas. And this is the major result that I have got as far as the model is trained according to the circumstances. I have got around 85% of accuracy by using CNN model, and by using the LSTM model, we'll be getting around 88% of accuracy. So when I have coupled both together, we can have good results such as 91% of accuracy according to the circumstances. So basically, the major reason is that we have some abstract data sets. This is the abstract data set that I have trained, but we need to enhance the data set so that we can have the production in a complete manner, so that we can gain the production and the cultivation both can be mapped together. So this is the abstract data set, which consists of 1,000 records. Only 1,000 records we have taken as far as the basic data set is concerned. We need to emphasize further to enrich that data set around 10,000 to 20,000 records, so that we can enhance the accuracy of the completeness of the records, so that we can enrich the complete model to the farmer's point of view. And this is the general reliable model that happens as far as the agriculture sector is concerned. So we need to emphasize it to the human being, aspect, as far as the user-friendly defined model that should be generated, that can be suggested as the future work of this particular project is concerned. And these are few of the references that take place. Thank you. Any questions? Yes, ma'am.
Yes, good sir. I have some questions. I have a doubt. How this drought crop viability using deep learning model or any AI model, I understood. Okay, CNN, RNN. How BCI will be a role in this one? I'm not clear about you.
BCI is mainly the current scenario in the AI domain, mainly regarding the brain computer, so that the farmer crop that is growing will be aligned with the farmer mindset, so that they can be mapped. So that is the major idea.
Second.
Okay, but what will be the data set for that one? How you are doing that one?
AI connection is not yet formed. This is an abstract idea, but we need to define it. We have an EEG format now, which consists of taking the sensor.
Along with the previous year crop input, are you planning to take any other input for making this possible? As you said, EEG input or maybe mental condition of the farmer. And your result, you are with only CNN plus RM model is there. BCI is not included.
Perhaps
your title it is there. Your title only it is there, but your introduction also you have explained, but while it is coming to result, you have used only AI tools.
In the data set, we have taken up the data from the EEG model.
Okay, can you what is the contents of your data sets? Is it image based or any time series data?
We'll be taking the sensory data, mainly the
Sorry,
robotic
voice
sensor
is
data.
sensor data.
Sensor data.
What it does it contain, images or text?
The soil consumption of the land and temperature that acts according to the farmer driven data.
Then how you can use a CNN? What is the role of CNN there?
Close the report like continuous as a friend and yeah. And
I think you have to learn more about this. Okay, sir.
Okay.
As a beginning, this is
We'll
good.
be focusing.
Okay. Okay. All the best. Sir, your voice is not audible, sir. Unmute.
Okay, ma. Okay, Ritvik. Right. Ma, next session. Next participant.
Thank you, Rutvik. Now I'd like to invite Chaitanya Krishna with holding ID 159 from Guru Nanak Institutions.
Sir, I'm audible, sir. Sir, I'm audible.
Yes.
Good morning, good afternoon, sir. Good afternoon, ma'am. I'm Chaitanya Krishna. I'm going to present my PPT. 1 second, sir. Sir, is it audible, sir? Is it visible, sir?
Yes.
Sir, my title of the paper is Sweet Dreams Powered by Machine Learning in
PPT
Sleep.
is not visible. PPT.
1 second. 1 second.
It is not visible.
1 second. It's getting stuck. 1 second. Sir, is it visible now? Sir, is it visible?
No, not share it. Yes, now okay, visible.
Sir, good afternoon, sir. Good afternoon, ma'am. I'm Chaitanya Krishna from 4th year of Guru Nanak College from CSE 1. My title of the paper is Sweet Dreams Powered by Machines, Machine Learning in Sleep Disorder Analysis. In this, my teammates are Ajay and Arvind Reddy. Ajay is going to start the introduction of the paper, sir. Over to Ajay. 1 second. Ajay, is he there? Okay, sir, I'll say the introduction. Okay, he's there, sir.
Good afternoon, everyone.
Unmute yourself, Ajay. Unmute yourself.
Everyone. Chaitanya, pass the slide.
I've changed the slide.
Chaitanya Krishna,
Uh,
unmute your mic, please.
Yeah, it's done. Okay, this is the abstract of our topic, sleep disorder analysis. In this, we have two disorders from sleep, like insomnia and sleep apnea. In sleep insomnia, the main thing is we can't sleep, and in sleep apnea, we are going where in the uh, middle of the sleeping, we are unable to breathe for some time or long time, which is so dangerous for our health. And this is the objective. We used first we used ANN, artificial neural network, for this topic, where the training is slow, and we now presented random forest based model for accurate results with 400 plus samples and 13 plus features. Existing system is CNN and ANN, which gives only 80 to 88.22 or to 88% of the results. And the disadvantages are high hardware demands and long training times. And the proposed system we proposed is random forest tree, where the predictions are high and the handles missing data is efficiency, flexibility in handling large data sets. This is the system architecture of our paper: data collection, data acquisition, data preparation, model selection, model training, and model evaluation, classification and sleep analysis. These are the modules: data collection, EDA, feature selection and engineering, data splitting, model training, model evaluation, model development, user interface development, testing and validation, deployment and monitoring. In data collection, we collected the data from the sleep EDF, which is also on internet, where we can collect the data from there, and the key attribute including unique identifiers, demographic details like age, gender, occupation, and health metrics like blood pressure, heart rate. Exploration of data analysis: analyze the distribution of each feature and target the classes. Feature selection and engineering: uses feature importance for random forest to identify the relevant features, perform necessary actions. Data splitting: split the data set into 80% of the training, 20% of testing, where we test the we are going to train the data set up to 80% and we are going to test the data set up to 20%. Model training: train the random forest classifier on training data like hyperparameters to optimize performance. Model evaluation: evaluate the trained model on the test set using metrics such as accuracy, precision, recall, F1 source, and the classification report. Model deployment and prediction: save the trained random forest model using serialization techniques, where we going to serialize everything and it's only step-by-step process. User interface: where we create an interface with the user for his data to be given, and will, as per his data given, we are going to provide the disorder what he has with the information. This is testing and validation: the test entire the pipeline with different inputs to ensure the model and the user interface work correctly. Deployment and monitoring: deploy the final system and we are going to monitor it for between a day or two for accurate precisions. This is the login page of our web. This is the login page where we going to enter the username and user password, which we can be created by our own. Like we can enter admin and password as your name, and we'll go to the next page where home and input page, where we are going to input our gender, age, occupation, sleep duration, quality of sleep, physical activity level, stress level, where this all data is given up to only 1 to 10, and enter BMI character with your weight, body weight, and enter heart rate, daily steps, blood pressure upper and blood pressure lower. After giving that, we are going to categorize it into three, like sleep apnea, insomnia, and none. If your data is given and if it shows none, then the result will be shown as none. If it's insomnia, it shows insomnia. And this is the future enhancement: we are going to expand the data set, further refining model parameters, because we only took 400 samples. In next technique, we are going to enhance it, because every day the technology is evolving. This is the conclusion, where we are going to help people by our web page to them to, as they should know their any disorders in them, in like sleeping disorder. Mostly people around 18 to 30, they are not able to sleep mostly of the time, by they are sleeping around 3 to 4 in the night, which can lead to sleep disorders. Thank you, sir.
Okay, thank you, Chaitanya.
Thank you, ma'am.
You said your evaluation metrics as accuracy, precision, F1 score, and all. How much accurate? What is the score for those things?
Ma'am, most in first our existing system was ANN, where the accuracy was 88%. After that, we have changed to random forest tree, where the algorithm helped us to 90% of the accuracy, 90 to 92%.
You are saying your random forest is working better than artificial neural network.
Yes, ma'am. The key difference is, ma'am, the model structure in ANN and which it comes to random forest, the structure is different and the training process is different.
Okay. Thank you. That's all.
Thank you, ma'am. Thank you, sir.
But in terms of accuracy, you have to tell, no, but not the training and all.
Yes, sir. I have
How
shown
we
you,
are
sir.
going to get that 90%?
Sir, 1 second, sir. I'll show you in the proposed system, sir. In this, oh shit, sir. So, in this, we got 88%, sir, in the existing system. In the current system, I have not mentioned it, but I'll mention it and I'll submit you, sir. 99%. Sorry, 90 to 92%. I have not mentioned it. Sorry, sir.
Okay.
Thank you, sir.
Right. Thank you, Chaitanya.
1 second. I'll stop the sharing, sir. 1 second.
Thank you, Chaitanya Krishna. Now I would like to invite Harish, holding ID 167 from Guru Nanak Institution's Technical Campus.
Yes, ma'am. 1 second, I'm sharing the screen. Is it visible? Hello?
Yes, visible.
Yes, sir. Shirin, unmute yourself.
Yeah. Good afternoon, everyone. Okay, shall I start, sir?
Yes. Shirin, go ahead.
Kindly switch on your camera during presentation.
Yeah, okay, ma'am. 1 second. Good afternoon, ma'am. Good afternoon, sir. Good afternoon, everyone. My name is Shirin, and I'm very excited to present our project title, a novel medical image encryption scheme based on AI decryption and encryption, by featuring encoding and decoding. It's all about, and yeah, I want to introduce also my teammates, Harish and Manideep. They are my two teammates. And going through this presentation, our presentation is about creating a system that protects medical images and by using artificial intelligence and QR code. By this, it will help us to turn our medical images very secure. It puts the images secure, encrypted with the use of QR codes, keeping the patient's data safe by using deep learning, AI, uh, and by resisting attacks like noise, cropping, hacking. These attempts may be getting into our files and all. This may help us to keep our data safe. And also, I want to mention in our in objective, in our objective, we have introduced that our goal is to build a secure system that protects our privacy of the patient and integrity of the medical data, which stores the key in the QR code. We will be developing a QR code to the patient for the particular patient, which ensures the only right that people can access it. Harish, can you select the next objective? Yeah, here. Yeah. In the objective, we are securing the AI-based medical images encryption system that ensures confidential. Like we doesn't want to put our data, we want to put our data private. So it will help us to secure our data with the help of the secure key that we have been presented in our project. And also, Harish, next slide. Introduction for the PPT. Medical, this all project is about the medical content, which helps to encrypt our crucial data. It will be protecting our privacy. So, private information will be uh, secured in a data, in a key, which will be only known for us and for the guardian we will be having. It will be slow and not secure enough. By using the GAN, we are present in this project. So existing system and proposal system will be explained by Harish, my co-teammate.
Okay. Coming to our project, our existing system was generative adversarial network for securing sensitive data. While GAN-based techniques can offer high level of encryption complexity, they come with several limitations. Training GANs is a delicate and computationally demanding. Yes, sir. Am I audible?
Audible, but on your camera.
Okay, sir. Sorry.
Yes.
Yes, sir. Moreover, the encryption and decryption process in GAN-based system can introduce considerable processing delays, making them less sustainable for real-time applications or environments with limited computational capacity. This inconsistency in output quality and the unpredictable nature of adversarial training also pose challenges in this project. So we came up with a proposed system. In our existing system, some of the drawbacks can lead to high computational resource requirements, unstable training process GAN, may produce inconsistent encrypted outputs, reducing reliability. So to overcome this, we proposed AI-based encryption and decryption scheme. This proposed system framework that combines artificial intelligence with QR code technology to enhance data security and usability. In this approach, user first upload a medical image which is then encrypted using a deep learning based algorithm. This process data into a secure format that cannot be interrupted without the current key. This unique cryptographic key, which is generated by the our AI encryption and decryption model, is encoded into the QR code using specialized libraries. So then both the encrypted image and the QR code key which securely stored and shared easily. For decryption, in this the user can scan and upload QR code, retrieve the key. The system uses the key and reversible neural network to accurately reconstruct the original medical image. Coming to our advantages about a proposed system, it simple and secure key handling via QR code, accurate image recovery using reversible network, easy key management via QR code, user friendly process for encryption, resistant to various attacks. Nowadays, most of using brute force attack are using random keys, so that it is resistant to such attacks. And the system and latter system architecture can be explained by Mandeep. Mandeep, unmute yourself.
Okay, now system architecture, plain text image. The process starts with medical image, likely X-ray, the encryption network, neural network, plain text as a input, transforms into encrypted version, keys generator. The compound generates the encryption keys used by both encryption and decryption networks. Decryption network. The decryption network cipher text image and key generator to reconstruct the original image. Cipher text image. This is the encryption version of the original image which should be unrecognizable without correct key. Decrypted image. It should be identical to original plain text image after description. Harish, next slide. Okay. Result inscription page. Inscription page text field for a security key. Next. Description page is the
Okay.
includes the upload QR code, choose a file button and text field for enter the description key. Conclusion. Our proposed AI-based medical image encryption system enhances the QR technology. Unlike GNA-based methods, it offers higher reliability, lower overhead, and resistance to attack like noise and brute force. By securely storing encryption key in QR codes, the system ensures efficient storage transmission and the control access to the medical images. This approach simplifies and encryption and decryption, make it a practical and secure solution for the
Yes,
protection of the
Manideep.
medical data.
Yes, Manideep. How you
Sir,
are developing that image encryption? What are the algorithm you are using for that? Are you using any algorithm for encryption?
so,
Yes, Harish or Manideep.
Yes, sir. We are using AI-based encryption and decryption scheme, which integrated with QR code technology. In this, we use deep
What
learning
are
for
that
encryption.
What are that technology?
Sir, it is a technology that we can, uh, sir, in existing system we have GAN based generative adversarial network, which the keys are not protected by the QR code, sir. In this our proposed system, we protect our the keys with the QR code technology. We include the key into the QR code, so that we can easily share our QR code to the end user. The end user easily scan the QR code to the get key. Then the key is used to decrypt the medical image, which is secured, sir. This is the benefit by our proposal system.
Hmm.
In existing system, the GAN is lagged due to the GAN generated the encrypted image after the several attempts. Sir, in this we can secure in the single attempt, and we can secure the key in QR code.
How you are evaluating the system? You said your system is more secure. How we can
Yes.
evaluate that one?
In our system, we while using GAN system, when we decrypt the the image which is encrypted, it's not decrypted. It is not equal to it. The percentage will be it's up to 80% or below that. It's not when it's comparable, it's not similar. After using our AI model, we secured it. It is up to 90%. The say similar image is decrypted from the encrypted image, ma'am. But I
What are the
didn't
accuracy
mention.
metrics you are using for? You are saying this 90%. Some proof is required, right?
Yes, ma'am. Most of the using old image, most of in 20 images, mostly likely 12 to 13 images are similar, which is when is decrypted. And in in proposed system, we took a example of 20 images, we uploaded, and we decrypted the 20 image. Up to 16 images are similarly decrypted, ma'am, so that we generated with our guide that most proposed system is very slightly better than
You
old
have to
system.
clearly said based on these evaluation metrics, your proposed system is working good. That is
uh,
important. Okay.
yes, yes, ma'am.
Okay. That's all, sir. Thank you.
Okay. Okay. My next Next person. Okay, thank you, Harish.
Thank you, sir. Thank you, ma'am. Thank you.
From 120.
Thank you, Harish. There's a small announcement. The time given for presentation is 6 minutes. So I request all the presenters to be mindful of that. And also now let us take a short lunch break. The lunch break timings are from 1:20 to 1:40.
Okay.
We'll
Can I
be
give the
back.
presentation right now?
Yeah, you can give. Please be
Yeah.
mindful that you have to present in 6 minutes. Okay.
Sure.
Okay. So I invite Manish Kumar to present the paper ID 168 from Guru Nanak Institution's Technical Campus.
Is it visible, ma'am? Sir, is it visible?
Not visible. Not visible. Your presentation.
Sir, is it visible now?
Yes, yes, yes.
Yeah. So good morning, good afternoon, sir. This is Manish from CSCC department. I am from Guru Nanak Institute Technical Campus. So I am presenting the major project on data-driven smart farming with climate focus. Our teammate consists of four members: myself and Abhishek Reddy, Amar and Joshna. So and the team of Narasimhacharya, and this smart farming. So we will go deep on the presentation of abstract, objective, introduction, and literature survey, and what is the proposed system and system architecture and exit system as well. So abstract, yeah, this is abstract, sir. So our project is a smart farm system. It is designed to help the farmers choose the right crop and to detect the diseases and get the correct fertilizer advice by using the artificial intelligence and real-time data. So due to climate change, unpredictable weather, and changing all the soil conditions, farmers faces a lot of difficulties in farming. So we are designed in these cases by using the machine learning and deep learning to predict the crop outcomes and diseases like what are the diseases affected by the leaves. And in this, farmers can use application to enter the basic details like temperature, rainfall, and pH, soil, and nutrition, and even leaf image as well. If we upload any leaf image or a web page, it gives all the information what are the disease faced and what are the affected by the leaf and plant. Then this help for the helpful suggestion using the AI models. This makes the farming easier and helpful for the more helpful and better
Manish, your
decision
voice is
making.
not clear.
And sir,
Your voice is not clear.
sir, is it visible? Is it audible now?
Audible, but voice is not clear.
Not clear, sir.
Okay, continue.
Okay, Manish, let me explain. Let me explain. Sir, I will go through. I will go through the PPT.
Switch on your camera.
I will start with the introduction. Yes, sir. Is it visible, sir?
Yes, yes.
Yeah. Yeah. I will go through introduction from introduction now. Like traditional farming struggles due to
tell me the technique or architecture.
Yeah, yes, sir. Yeah. Okay. I will go through existing system. Most current systems work in isolation, like one for soil and one for weather and one for climate changes, etc. And they are all based on rule-based techniques and not algorithms like dynamic algorithms. They are static-based algorithms. They depends upon the data which is given statically to the system, which are less effective in complex environments. Like we proposed a system which is AI and climate APIs using IoT sensors data, which is real-time and dynamic, which can be adapted to any place. And we are recommending crops, diseases, and fertilizers to the farmers. This helps improve yield. And algorithms used are random forest algorithms, and LSTM, long short-term memory algorithms, and CNN LSTM hybrids. We mix both the algorithms, like not isolating them. We are combining them to predict more efficiently and effectively to the problems. We are taking these data from IoT sensors in the future, and for crop prediction, we are taking pH values, nitrogens, potassium, and other nutrients to predict the crops. And for detecting the diseases, we are taking image as a condensed data from the users. And system architecture, we include ML algorithms. We are inputs are taken from the farmers, and some of the inputs like disease prediction are taken from the drones in the future, and they are directly sent to the model. And model is trained in such a way that random forest training is applied, and also LSTM is applied, and long short term, which will take long years of data and predict the future recommendations. And we have future enhancements, like we use AI chatbot for farmers, which is multilingual to understand the farmers, like predicting and solving queries. And we use blockchain technologies to secure data, and user friendly and transparent website we are going to develop it. And I conclude that, and we use real-time monitoring and climate data APIs to predict the data and predict crop yields. These are the algorithms we are going to use, and this is our titles. Thank you.
Yes, what is the use of that random forest algorithm? Why you are using it?
Yes, sir. We use three techniques actually: random forest, CNN, and we are using LSTM. Random forest is majorly used for crop recommendation, which is like avoids overfitting of data, and which is very much effective in smaller data. We are using for fertilizer suggestions. It is robust to noisy data. Works well with tabular data. We are using like nitrogen, potassium, and pH values, rainfall data. So it is better for tabular data.
Already drones are using in crops, no? So is there any difference for that?
Like they are not using for detecting diseases, sir. They are only used for like some needs, like pesticide irrigation and fertilizer dissolvent.
It is researchers are there, research papers are there already in this area.
Yes.
Okay,
Yes,
many
ma'am.
research, only one thing is that it is not reached to the farmers. Okay, many researchers are there for disease detection based on the climate condition, IoT devices. Many research papers are there. Only one concern is that it is not reached to the farmers.
Yeah,
for that, what you are going to do?
We are developing a website, ma'am, which is user friendly website. Just it has an interface, and the farmers are going to give them nitrogen, potassium, pH values, rainfall conditions, if any, and if not, we are taking from climate APIs.
As an input, you are asking the farmers to give. If they are this much educated, what is the need of this?
Yeah, that is what I included, that we are going to develop an chatbot, AI chatbot for multilingual purpose.
No, not multilingual product. How can a farmer know the exact amount of nitrogen, soil moisture, pH value in a certain area?
Yeah, we are going to take this data from IoT sensors, as I included in future.
Okay, fine. IoT sensors, it is based on that. Then next thing is that one data set. From where you got the data set for training?
Firstly, we got data sets from like Kaggle data set. And
all these combined data set is there.
No, ma'am. Like we have Kaggle data set separately for disease prediction, and we are going to take real data from Palam Institute of Technology Agriculture. You can search that. You may know that from Mahabubnagar district we have Palam Institute of Agriculture Institute. Like we are asking them for data sets.
Currently you said you have trained, right?
Yes, ma'am.
Which data set you have used for that?
We have used Kaggle data set.
Everything is different. How can you combine? That is data set. That data set may be from US. right? Image from US, soil data from anywhere from India, and weather data set from somewhere. All these have one connection, right? How you
Yeah,
are
yes, ma'am.
connecting them?
If you want to do that, we have to collect the local data sets. Will
Diseases must be depend on weather or soil condition, right?
leaf data. We are taking leaf images, ma'am. We
Well,
are taking leaf images.
diseases is depending on maybe soil condition, weather, and everything has a connection. According to that only you can suggest fertilizers. So everything
Yeah.
has a connection. So
Yeah.
you have to collect real-time data with IoT devices. With that only you can train the model, and only
Yeah.
your prediction will be accurate.
We can use
And your
recurrent neural networks.
suggestion of fertilizers or pesticides must depend on the weather or soil
Yes, ma'am. Yes,
condition.
ma'am.
Everything must be
Yes, ma'am.
considered.
Yes,
Okay,
ma'am.
all the best.
Yeah, thank you.
Okay, okay, man. Thank you, Abhishek. Thank you.
Thank you, sir. Thank you, sir.
Okay.
Manish,
Yeah,
would you like to post your research paper in journal?
sure. No,
No. We just want to know the information.
Yeah, we will discuss with our teammates and we will let you know.
Okay.
Yeah, thank you.
Okay, now let us take a lunch break, short break. Next, Harini, please be ready after that at 1:40. Please be on time. We'll carry out the session later, after 20 minutes. Thank you.
Kala ma'am. Hello,
Yes,
Kala
sir. Yes,
ma'am.
sir. Yes,
Madam,
sir. Yes, sir.
we can join at 1:40 minutes.
Yeah, sure, sir. Sure, sir.
We'll take your
Thank you.
lunch. Okay, ma'am.
Okay, sir.
Thank you.
Hello. Let us now begin with our presentations. Yes, sir.
Good morning, sir. I am from R&D team. I will present you the PPT. 1 second. I will share the PPT.
Okay, Saitesh. Okay.
Is my screen is visible?
Yeah, good afternoon, everyone. This is Ritika from Nanak Institution Technical Campus. I am giving presentation on the topic of enhancing sarcastic detection with NLP and CNN model. Going to abstract, our project explains about the sarcastic detection. This is a task in NLP, where NLP stands for Natural Language Processing, where the system tries to identify a piece of the text like a review or a message in sarcastic or not. This sarcastic happens when someone says something but actually means that opposite, often the mock effect. This method is used for techniques in CNN and NLP. Coming to objectives, in this project we use in this study of project we develop the techniques like CNN and NLP, where CNN is helpful for is a type of a deep learning, and it is used for analyzing the visual data like images and videos, and also and other type of the data is like text. As, and this detect the pattern and features like textures. And coming to uses of CNN, it classifies the images like mm, by using the object detection and face recognition. With this, we can by this text it gives the images. Next, coming to NLP. NLP stands for Natural Language Processing. It instructs the computer science and artificial intelligence. It focuses on enabling the computer to understand and interrupt the human language. And next, proposed system. In existing system, we use the logistic regression. It uses only binary values like 0 or 1, 2 or false, etc. It gives an exact solution, which is simple and most effective. It gives more accuracy also. Coming to proposed system, we use CNN. It classifies, it is used on deep learning, which proposes structures like grid language and also. And next system architecture will explain our team at Saitesh. Thank you.
Yes, sir.
Good morning, sir.
Yes.
As we are using CNN model, we have system architecture like we have to give input to the website. We have different layers in that. First one is conventional layer and second is pooling layer. We have multiple layers from like conventional layer and pooling layer. Conventional layer is used to reduce the size. Like it is using like filters. It is used to remove the unwanted text from the sentences. Pooling layer is used to reduce the size of the text by removing the unwanted text. System module. We have different modules like data set. First, we have to give the data set to the model. The data set contains structured data by which is labeled or unlabeled. And next we have data cleaning. We need to remove the all errors present in the data set like null sets and etc. And pre-processing the data. In pre-processing, we have to transform the raw data into format data. Next, splitting the data. We have to split the data into two different sets. One is for training and one is for testing. After we have to apply the model to that training purpose. After applying the model, we have to evaluate the model by checking the accuracy, whether it is giving a good accuracy or not. Next, prediction. After model execution, we have to it will predict the output of the text, whether the text is sarcastic or not. This is our execution. In this, we see that we have to give the input in the input field, and after giving the input field, we have to go for the prediction. Go to the prediction. After that, it is used to predict the whether the text is sarcastic or not. Future enhancement. In LLMs, there is no zero shot scenarios, so we have to improve the model by training the model with a large number of data sets. By that, it can enhance the system LLMs so that we can get the zero shot answers. Conclusion. In this website, in this project, we are going to predict whether the text is sarcastic or not. Thank you, sir.
Hello.
What is your data set? Which data set you have used for training?
Sir, ma'am, we are collected from Indonesian data set, ma'am.
You have collected or any? It
no,
is available
from Kaggle data set. From Kaggle data set, ma'am. Kaggle website.
Okay. This sarcasm may vary, depends on the countries, right? The people
Yes, ma'am.
there. And how you can find that one?
By taking different data sets, ma'am. For example, India. Coming to India, we have to take the language which are spoken by English, our Indians.
Which AI model you are using?
CNN model, ma'am.
CNN model for text.
Yes, ma'am. For testing and understanding, ma'am.
I can't accept that one. CNN model used for natural language processing for text analysis. How can you say that?
Whether the text is sarcastic or not, by giving training, ma'am.
Which platform you have used for implementing this?
Python, ma'am.
Python. What is your format of the input? Is it text or images of
text format, ma'am? Text format. We have given text, ma'am.
Text with the CNN model. You have done?
Yes, ma'am.
Are you sure? Who is your teammate?
Ritika, ma'am.
Yes, ma'am.
Ritika also, you are also sure about that?
Ma'am, for pattern we use NLP model.
NLP model. NLP is natural language processing.
Ma'am,
the model is used to.
Ma'am, for CNN we use pattern, ma'am.
Pattern recognition.
My question is, what is the input format?
Text format, ma'am.
Text format which you have used. What is your AI model for using that one? Model.
We just used CNN model, ma'am.
That is wrong. Then you won't
Ma'am,
get the
NLP.
NLP is not a AI model. It is an area under AI. Okay, leave it. I think this has to work more. As per my knowledge, it won't get result with ANN. Text can't be processed with ANN. In case text is converting to image, it may be processed. Okay.
Okay.
Okay, thank you.
What is logistic regression? Sir, Saiteja?
Sir.
Logistic regression.
So logistic regression is used to, it is a binary classification, sir. Whether it is used to classify based on the input, sir. It is used for classification the data, classification of data into zeros and ones and true or false.
Okay, okay, Saiteja. Right. Thank you.
Okay, sir.
It's next batch.
Thank you, Sai Teja. Would you like to post your research paper in journal?
We will intimate you later.
Okay, thank you. Now I would like to invite Jannavi, NCFT ID 198. Jannavi, are you there?
Okay, next I would like to call Abhinaya, paper ID 201 from Guru Nanak institutions to start their presentation.
Good afternoon, everyone. This is Abhinaya. Just give me a minute. I'm presenting my PPT.
Directly go to existing and proposed system and system architecture.
Yes, sir. Our project is about blockchain assisted hierarchical attribute based encryption schema for secure information sharing in industrial Internet of Things. This is a project where this tells about
Not audible.
hello, am I audible, sir?
Yes, yes. Yes, start.
Yes, sir. Our project tells about the cloud, which we use to store data from one step to the other step. Where if the user want to store the data into the cloud, they have to have a user ID and password.
Must switch on your camera. On your camera. Yes.
Yes, the algorithm we use for storing is security analysis. Data is stored in centralized cloud servers. Security release on traditional encryption mechanism requires a trusted third party for access control. Here we will be having a third party called cloud, where the user stores the data into the cloud and the cloud stores it with an encryption format, where again the user need to access the data. He need to have a password and an encryption code to decrypt the data from the cloud. If they enter the cloud, they enter the password and username onto the cloud, then only he'll be able to access the data which he has sent to the cloud. The challenges faced by this is vulnerability to attack and breaches, high authentication latency, no decentralized access control. The drawbacks are risk of data and exposure to unauthorized users, trust issues due to centralized control, difficulty key manage and distribution. The proposed system for this project is implements hierarchical attribute-based encryption for fine-grained access control, uses blockchain to ensure tamper-proof authentication and data integrity. The project that we have implemented will be having a step of tamper-proof authentication and data integrity, like the third party or the third person who did not authorize the data will not have access to use the data. And the advantages of this project is enhances security, prevents unauthorized access and data tampering, efficient data sharing, decentralized storage, reduces data retrieval delays, fine-grained access control. Only authorized users can access specified data. No third-party dependencies. Eliminates trust issues. We don't have fear of misusing of our data by the third-party people. This is the proposed system for projects.
Yes, next, do you have system architecture?
Yes, sir, we do have that. This is our system architecture, sir, where the data user stores the data into the cloud server within the multiple, where the data user will give the data in single format and the cloud separates the data into different nodes to secure the data and stores the blockchain format. This is our system architecture, sir.
Okay, ma, Abhinay, what is that blockchain technology? What is the use of that blockchain technology?
Blockchain technology will be having an access of all the nodes in one cloud, sir. Like if we have the different data in the separate nodes, we'll be having one data case to store the data with different nodes. Yes, sir.
Here, what is this fine grain access control? What is the use of that? Yes. Abhinay? Madam, ma'am.
Yes. Have you simulated or implemented the model?
Implemented also. We did that, but at present, the project is not in my laptop. It is in somebody's laptop.
Which platform you are used for that one?
We used Tomcat server.
Okay. How you are saying that your model has working better than the existing system? Based on what you have evaluated that?
In the past systems, it is also effective, but not like this. they will in the past like in the past clouds they will be having some access for the third parties. They do some major changes, but in ours we will be having an encryption data code where we will be giving when the user add their data to the cloud. If they enter that data code only, we can access the user's code, user's data.
Okay, okay. Thank you. All the best.
Okay. Let's take the next presentation.
Thank you, Abhinaya. Would you like to post your research paper in journal?
I'll let you know, Petra. Thank you.
Next, I invite Janvi to present the holding paper on paper ID is 198 from Guru Nanak Institution's Technical Campus. Good afternoon, sir. Am I audible?
Yes, audible.
Yes, sir. I'll share my screen.
Fast.
Okay, sir. So the title of our project is Novel CNN Model for Facial Recognition. In this presentation, we'll be going through all of these like abstract, objective, and introduction, and all the things. So coming to the abstract of the project. So facial recognition is has become one of the most important things in nowadays. So to improvise this recognition technique, we have used this CNN based model, which will be helpful to extract even a minute spatial features uh, and improves the performance. And the main objective of project is to improve the efficiency and to improve the feature extraction and to improve the performance. In existing system, we have used MSCA, that is multi-scale convolutional attention model, that combines both the multi-scale feature extraction and attention mechanisms. This is also very helpful model, but uh, it is computationally overhead, and it consumes more amount of memory. So to overcome this, we have used the CNN model to recognize the facial features. So the main drawbacks of this is it has huge memory consumption, and it is computationally overhead due to combination of different multi-scale feature extraction and attention mechanisms. So with the help of the CNN model, we will be able to we will be we are computationally efficient for image processing tasks, and it improves the performance. Like even the minute expression in a person's face can be recognized by using this model. So coming to the system architecture, we have five layers. The first thing is an input layer. So in input layer, we will be receiving an input from the user, and next in the convolutional layer, we will be extracting all the bits from this layer, and will be sent to pooling layer. The pooling layer will erase all, any kind of blurriness and everything, and will send to the fully connected layers. So here we will we will rearrange all the bits and form an output and send it to the output layer. The system requirements will my teammate Preeti will tell you all about this system requirements. Thank you, sir.
Share this.
Okay, yes, you are Janvi, no? Hello?
Yes, sir. Sorry, sir. There is some technical issue.
Okay, how you are getting that efficiency, efficiency and future extraction? How you are getting more efficiency for your project?
Sir?
Efficiency. How you are getting that efficiency, more efficiency?
Uh, in the CNN model, like in each layer, the image that is being the image that is being produced by the user is detailedly extracted. Like even the minute feature will be extracted. So any kind of expression, like we'll be having a trained data set, sir. With the help of the
How you
data
are extracting? What way you are extracting? Are you using any method for that?
CNN model, but with the help of CNN models.
Mm.
So in the CNN model, we have 5 different layers. No, sir. So with the help of each layer, the image will be the expressions in the image will be detailedly extracted. So we can easily identify the emotion of the person.
Which optimization algorithm you are using for training?
Huh?
Which optimization algorithm you are using in CNN for training?
Which optimization? CNN, ma'am.
CNN is an AI model. Do you know what is back propagation? Okay, fine. What is the role of pooling layer?
Huh?
Pooling layer in CNN.
Pooling layer. Just a minute. Pooling layer is used to clear the blurriness and everything in each bit.
What are the various type of CNN model? Which one you have used? Okay.
Okay,
Okay.
Okay, Janvi. Thank you, Amma. Thank you.
Okay, Janvi, are you willing to present your paper in general?
We'll let you know later.
Yeah, okay, thank you. Next, I would like to call upon Ankit Kumar, paper ID 204 from Guru Nanak Institution Technical Campus, to present the paper.
Good afternoon, sir. Good afternoon, ma'am. Am I audible?
Yes, audible.
Sir, 1 second. Sir, is it visible, sir?
Yes. Yes.
Good afternoon, everyone. My name is Ankit from Guru Nanak College. So my title is Unit for Precise Segmentation of High Resolution Aerial Images. So coming to abstract, a few short semantic segmentations in aerial images, challenges due to limited data and varying object orientation. A new method combining unit and efficient net proposed to improve segmentation accuracy. So the main objectives are for developing a model for aerial image segmentation using a unit and efficient net to improve segmentation accuracy and reduce misclassification like land use classification, disaster response. Coming to existing system, the traditional method struggles with semantic objects in aerial images when they appear in different orientations. The proposed FRI-net model improves recognition of rotated objects by extracting features. The proposed system, the proposed efficient unit combines the strength of unit and efficient net to better segmentation of images. The proposed efficient unit improves accuracy by aligning features of same category objects of orientation. So coming to system architecture, so for the first step is data preparation, and the second step is data augmentation, and the third step is model training, and the fourth step is model evaluation. In the fourth step, after the training, in the different various data set, it is trained. So coming to system modules, first one is preparing the data. Preparing the data is nothing but collecting the data from different fields. Second one is model design and development. Developing a unit model with an encoder and decoder structure. Third one is testing and optimization. When there is any loss function, we should optimize the optimize it. Fourth one, evaluation validation. Access model performance and compare it with previous models. Fifth one is integration and deployment. Integration train model into an automated system. Coming to execution screenshots. First one, we should register and then we should log in. Third step, we should choose a file and give original image that will segmented into threshold segmentation, edge segmentation, and k-mean segmentation and original segmentation. That's it.
Yes, Ankit Kumar.
Sir.
What is short segmentation in serial imaging?
Sir?
Short segmentation.
Short segmentation.
What is that?
Sir, by using efficient net, by using efficient net, we can scalable and efficient the image.
Okay. What is UNet and efficient net? What is the difference? UNet and efficient net.
By using efficient net, we can scalable the image.
UNet.
Unit. Sir, unit is nothing but we can encode and decode the structure.
U means? What is the meaning of that U? Okay. Madam.
Okay. What are the other segmentation techniques? Why you prefer exactly unit?
Ma'am?
What are the other segmentation technique? Why you prefer unit over others?
For a specific image, we should segment it with.
Segmentation is okay. Many segmentation technique is there. Why you prefer unit? Have you tested with any other segmentation algorithm?
No, ma'am. Didn't test it.
Why you prefer? How you happen to know that UN is working with efficiently?
Actually, I tested with only one image.
You have to test various algorithms with the different images. Then only you can able to say which one is working with your data set. Okay, that's all. Thank you.
Thank you, Ankit. Would you like to post your research paper in journal?
I'll do it later.
Okay. Next, I would like to invite Amina. Amina, start your presentation.
Good afternoon. This is Amina from Ncft. So I would like to present my testimony. Good afternoon, everyone. This is Amina. My title of the project is Sonic Sort, Advanced Classification of Music Genre. So basically, the abstract here, we're going to take different music genres, different kind of genres in which we can include different hip hop music, disco music, any different kind of music. We're going to take a random audio file that we're going to sort it into. So introduction is
Amina,
like,
your voice is not clear.
is it now, sir?
Mm.
So basically we are going to use GTZan data set. Here in this data set, there is about 1,000 of different audio files, random audio files that is being distributed in 10 different genres. Basically, using this data set, we want to train the model. So existing system next, there are already existing systems Spotify and Shazam using based on the audio and features, we want to sort the audios. So based on our case, based on our emotions and everything, we will get the recommendation based on our mood.
Voice is not clear, Amma.
Now it's audible, sir. Hello.
Yes.
In this system, using the GTZan data set, that different genres we are going to classify, and the model is being trained, the model is being tested, and then the model will start the prediction. So next to the design methodology, extracting the features from the model. Use the data set, extraction of the features, then the model will check accuracy. If the result is good, it's yes, then it's go again. Then a new model is continued and exact same features used model. You want to predict the genre if it's a rock music or a different kind of music. Implementations analyze different music features based on their say metro spectrum data, based on the accuracy of the data. How accurate is the graphical knowledge compared to other models?
Your audio is not clear. Sorry.
Now is it clear? Is it clear now, sir?
Mm-hmm. Yes, which data set we are using for this?
Is it clear now, sir?
Which data set we are using for this?
Yes, sir.
Which data set we are using for this project?
GTZan data set, sir.
Who is the end user of it?
Yes, sir.
Who is the end user of this project?
End users is basically we gonna music composers, some of the members who are really interested in music, that it's very helpful for them.
Okay, how you have chosen only accuracy as metrics? This kind only why you have chosen performance metrics as only accuracy. Other metrics is there, right?
Basically, this is the graphical music is like based on the graphical knowledge is gonna differ. So through which we're gonna separate the audio files. So graphical knowledge and the using
Why
different
you
audio.
prefer, my question is clear, right? Why you prefer accuracy as evaluation metrics in your project?
Accuracy, like ma'am, every genre has its own accuracy. Like basically every, like example for rock, it's like 97%. So if the data, graphical data is up to the accuracy of that point, then it's sorted into that. So every different have its own accuracy. So based on the accuracy, it's helpful here to distribute.
Okay, okay.
And next question, like
Yes, ma'am.
conclusion.
Okay, thank you.
Okay, ma'am. Thank you. Thank you, ma'am.
Thank you, Amina. Would you like to post your research paper in journal?
Yeah.
Okay.
Yes, I want.
Okay.
Thank you.
Okay, next I would like to call Sairam, paper ID 21214 from Guru Nanak Institution Technical Campus to present the paper.
Good afternoon, sir. Good afternoon, ma'am.
Yes.
Yeah. Just yeah. Good afternoon, sir. Good afternoon, ma'am. Our project is experiment detection of depression in social media content using NLP model, ma'am. Just a minute. Is it visible, ma'am?
No, no, not visible.
No, sir.
No.
No. No, sir. Is it okay?
Now okay. Now okay.
Yeah, yes, sir. Our project is on detection of depression in social media content, sir, using NLP model. The main aim of the project is to detect the depression text on the social media platform using NLP model, where we classify this text into two types, where it is a depressive or control text, where we can use the we are using test data like mental health data from different platforms, and we are concluding this data to a NLP model uh, for detecting the depression, and where we classify this post into two groups, like control text or depression text. And for classifying this text into two groups, we are using LSTM model. As we know, LSTM long short-term memory, which is a special type of memory designed to learn and remember the information over long sequence of data, and it is a special type of RNN model, sir. And we are the main aim to create a tool that detect the depression in mental health data to identify whether the text and data is related to depression or not. And next is continued by our teammate existing system and proposed by Shreya, sir. Shreya.
Who is your teammate?
Shreya. Hello.
Hello.
Yeah.
Okay. Coming to existing algorithm, we are using CNN network CNN model, that is convolutional neural network. It is a special type of deep learning neural network. It is primarily designed for processing structured grid like data such as images, audios, and time series, etc. And it have proven to be highly effective in tasks like image recognition, object detection, and natural language processing. Uh, and it will detect the special features like edges, textures, shapes, etc. But it will have some drawbacks. It will have high computational cost. And we should train the large data set. It is waste of time, and it will have the lack of interpretability. uh, Coming to the proposed system, we are using the LSTM and gated GRU both models. Uh, Coming to the long short term memory, it will have the in memory cell which stores the information over the long sequences, and it is basically used for storing and handle the sequential data. And it will have the three gates, which are input gate, forget gate, and output gate. Coming to GRU, it will it is the advanced technology or algorithm of LSTM. It will have the two gates, which is input and forget gate as one, and output gate. Uh, it will reduce the complexity of the model, and it will increase the performance of the model. And it will have the more advantages like it will detecting the depressive content, and maintaining the stable health condition. And it will give you high accuracy. It will have the automatic analysis about system architecture. First of all, we are taking the sequential data input, and we are giving this input. No, we are taking the input and we are cleaning the data like white spaces, unimportant data. And these data we are giving to the LSTM and GRU. The GRU will extract the features, and we will train the model. We will train the entire data set by using two algorithms, and we will predict the output, that is whether the data is depressive or control. Coming to the screenshots, this is the home page where we have a home of abstract login page. And in the abstract page, we are having the project abstract all. And this is a login page. We should enter our email ID and password to get the access. And we have taken the sample data, test data from various social medias and from references. And we are giving these data to predict the result. And we give this predict we are giving this data, and we will predict the text whether it is depressive or control. And this is the accuracy of the our project.
Shreya,
Yes, sir.
can you give the example of that? Any sample copies of that
Sir,
results? Any examples for the diffraction model or diffraction text in social media? Do you have
so
any example?
sir, like in social media like Instagram or no sir, we are taking only text data, not images or audio video.
Mm.
like Google,
Okay.
ChatGPT.
And how you are overcoming that lack of interpretability?
Sir,
How you are overcoming that interpretability? It's said that in existing system there is a lack of interpretability. So how
yes,
you are overcoming in that?
sir.
Yeah, yes, sir. Actually, in existing system, we used a CNN model, sir. So, as come to earlier, we proposed the LSTM GRU so that interruptibility will be improved by this GRU mechanism where it uses the three gates mechanism, sir. So that interruptible will be implemented by this mechanism, sir. By this deep learning process, the accuracy will be developed and also all the
Okay. Okay.
disadvantages will be able
Okay.
developed.
What is the difference between LSTM and GRU?
Ma'am, LSTM will have the three gates, and it will store the information for the long time. Coming to GRU, it will have the only two gates. It will decrease the complexity and it will improve the performance. We are adding LSTM in both GRU as one. We are taking two algorithms.
Have
We are
you
making
have
more.
you found any existing study which is combining LSTM and GRU?
Yes, ma'am. Existing CNN model.
CNN is different. CNN is for images. Here you are only considering text from the social media.
Yes, ma'am.
Nowadays, who is posting text in social media? Very less content. Everyone is posting images, or if even if it is quotes, also it is in the image format. How you can solve this issue? How you can solve this issue?
No, ma'am. Actually, we are predicting only text data from the social media content. Actually, we are not going through image, ma'am.
Images, audios.
Yes, yes. Nowadays, I'm asking you socially.
Yeah.
Nowadays, everyone is going behind images, video, Ghiblis, and all those things, right?
Yeah.
So
Yes,
you
ma'am.
are saying only text you are taking means
Yeah. Actually,
will it be
uh,
useful?
yeah, yes, ma'am. Actually, this will be useful for predicting the mental health of the date.
Yes,
Mental
yes.
health.
I'm asking you now.
Sorry, ma'am.
How everyone is using
Yeah.
images only for posting, right?
Yes, ma'am.
If text is also is there, that is on the image, right?
Yeah.
Quotes
There
we are
are.
posting one some background image, right?
Yeah. Yes, ma'am. Yes, ma'am.
Only with the text very rarely or some news only maybe is coming like that. And
Yes, ma'am.
also
But
LSTM is combined. GRU is overcoming the limitation of LSTM.
yeah.
That's why GRU is existing. Then you are again combining GRU with LSTM. It won't be a good method.
Okay.
Okay.
Yeah. Yes, ma'am.
Okay. That's all.
Okay. Yeah, sure.
All the
Thank you.
best.
Thank you. Thank you.
Okay. Thank you. Thank you, Shreya.
Okay, thank you, sir.
Sairam, you haven't published your full paper yet. Please do it as soon as possible.
Sure. Sure. Yeah.
Yeah, okay, thank you. Okay,
Thank
next
you.
I would like to call Swarna Lata, paper ID 215 from Nanak Institutions.
Good afternoon, sir, and good afternoon, ma'am. I'm Swarnalata from Guru Nanak. Is my screen visible, sir? Hello?
Yes. Yes. Yes, Swarna.
Okay, sir.
Continue.
My project title is AI-based neck direction prediction and analysis using YOLO V8. In this, we are going to discuss about abstract, objective, introduction, literature survey, and system architecture. And the following are will be discussed in this. And this project mainly focuses on predicting and analyzing neck direction using head impacts using YOLO V8 model. and it is a powerful real-time object detection tool. The main objective of this project is to prevent injuries by tracking neck movement, and by monitoring the neck's position and orientation. This model will help to predict its movement direction during head impacts. And we use YOLO V8 model to track and analyze neck protection during head impacts. And the introduction of this project is focuses on accurately detecting and tracking neck rotation during head impacts. And these model ensures transparent and interruptible insights, and which will be aiding clinical decision making and improving safety measures. And the existing system for this project is extreme gradient boosting model, and it is also used to predict the neck direction based on biochemical data. And this is also powerful machine learning algorithms. And in this existing algorithm we were having some drawbacks compared to the proposed model. This is very simple, and this model will take longer time to train, and the predictions will also be difficult by using this tool. And the proposal system is YOLO V8 model. You only can look once, version 8. It is a highly advanced object detection model which is used for tracking neck rotation during head impacts. And the YOLO V8 model normalizes the data to ensure the consistency and enhance model performance. And when we coming to system architecture, in the system architecture we will be giving an input image. The input image will be a human face or upper body image, will be taken as image. And in the image analysis, we'll initially we will do the pre-processing of the image to detect the input given input image. And in the feature extraction, it is important that we need to know the position and direction and orientation of the face. And in the YOLO model will be applied for the input image to get output image. And in we'll get output image through YOLO model. And we will be having some system modules like data collection, model selection, and labeling, testing, and deploying. And these were the snapshots of our project. And we will be firstly we'll having initially homepage where we need to choose a image. Here we have chosen an image, and finally we will get the output. This is original image and detected image. In the detected image we will know in which direction the face was kept, or in which orientation it is there. And the future enhancement of this project is there will be three head. There will we can get the position of the neck very easily, and there will be emotion and expression recognition, and the pose estimation, and real time results. And I'm concluding this project by, in the conclusion, by this project we'll get efficient detection. The YOLO V8 model enables real-time and accurate tracking of neck rotation during head impacts, and will get injury prevention, and there will be future scope by using YOLO V8 model.
Yes, yes. What is this Allo V8 model, Amma?
So the YOLO V8 model is you only look once. It is a powerful real-time object detection tool, sir.
What is the difference between previous one and this one?
The previous one is extreme gradient boost model. It is an existing model. In that model, we will be getting, we will not get accurate results. But in the YOLO V8 model, we'll get accurate results, and there will be live results in the YOLO V8 model, but we'll not get the live results in the existing model. And the existing model will take longer time when compared to YOLO V8 models.
Okay.
YOLO V8 model is also existing for object detection, right?
Yes.
Then how we can say it is a proposed model?
For knowing the orientation of the head or direction of the head, this tool is
it is an existing tool. You are saying it is a proposed tool. How you are evaluating your model? Which
by
data set you have used?
will give as the input as image, no? Image
Which
as a data.
data set for training? Data set, which data set you have used? You have created data set or already existing data set you have used?
We have used already existing.
Okay, fine.
Okay, Swarnalata. Okay.
Thank
you. Thank you, Swarnalata. Would you like to post your research paper in journal?
Will inform you.
Okay. Next, I would like to invite Archana to present the paper holding Ncft ID 216 from Nanak Institution's Technical Campus. Over to you, Archana.
Hello, good evening, good afternoon, everyone. My teammate Srikar will be starting the presentation. Over to you, Srikar.
Yeah, good afternoon, everyone. Today we were here to introduce about our project. So, is it visible? Yeah, good afternoon, everyone. So the title of our project is called YOLO V8 based sunnet coffee leaf disease detection using a hybrid deep learning model. So my teammates are Archana and me and Pradeep. So the overview of the presentation is this: we'll be going with abstract and then objective and introduction and existing proposed and architecture to models too, and then the conclusion with after execution. So coming to the abstract, so the project mainly deals with the coffee plants. Like usually coffee plants prone to many diseases like brown eye, leaf rust, leaf miner, and red spider mite, which can actually impact the both the yield and the quality of the coffee leaves. So if we tackle them early, we can actually minimize the crop losses and improve the coffee production as well. So to tackle this, we have introduced a new technique called YOLO V8. It is an advanced efficient object detection model for its speed and accuracy. So we propose this with a practical and scalable solution for a disease monitoring. So the product only detects the diseases in the coffee leaf detection. So when it comes to the objective, like we provide a practical and scalable solution for disease monitoring, so which could minimize the need of the pesticides. So it also helpful for the farmers to quickly identify and treat the affected plants. So we utilize this using YOLO V8 deep learning model, which is very speed and accurate. So it is also having a lightweight architecture for the deployment on devices. So when it comes to the introduction, coffee is an important crop for each one of us. So these diseases coffee leaf disease could actually make a huge impact in the society. Like it could bring the economic losses for the farmers as well as the coffee industry. So there is a need of new and innovative solutions for this. So we coming to the existing system for this solution. So there are many advanced deep learning models like technologies that could detect and classify the coffee leaf diseases. So some of them we use using the neural networks like unet and segnet for the semantic segmentation. So it having like a VGG16 architecture for the feature extraction, and the decoder with the skip connection is actually preserve the spatial details and accurate reconstruction of the segmented areas. So then the next one will be the existing system. We use the CNNs as we know. So the drawbacks of this existing system are which is very complex. There will be like a real time limited to the real time applications, and overfitting risk will also be there. So then next one will be the proposed system will be explained by my teammate Archana.
Good afternoon, everyone. Coming to proposal system, our project proposes a YOLO V8 model, which is a state-of-art deep learning model. It is used majorly for real-time disease detection and classification in majorly coffee leaves. And our project aims to build robust system by integrating various techniques like data augmentation, transfer learning, and hybrid deep learning with YOLO V8. And it is designed to be fast, accurate, and efficient for detecting the diseases in coffee leaves. And due to its lightweight architecture, it can also be deployed in devices like smartphones, drones, edge devices, which helps in keeping track of the diseases that are occurring in the coffee plants. Next slide. So the major advantages of YOLO V8 comes are it is very efficient in small data sets compared to existing system which uses CNN. It is used for majorly large data sets, and it does not provide efficiency in smaller data sets. And YOLO V8 is majorly used for real-time object detection, and the accuracy and speed of YOLO V8 is also more compared to CNN. Next is system architecture. The data set which we have used is divided into three parts: majorly training set, validation set, and testing set. Training set is data augmentation is performed again on training set to extend the training set, and this various images from this training set is given to the model, and the results obtained are again compared with the original disease files. And validation set is used to again test whether the model is working properly or not. And lastly, it is evaluated using testing set, and the output image will be in the form of the disease is highlighted with a box around it, which helps in uh, easy detection of diseases. Next is there are various system modules in the process used. The first one includes data collection, various images from the field cameras, drones, etc. Collected and stored in one place. Uh, collecting images from various sources involves the images are collected are from various environmental conditions, and the data collected is again pre-processed. The raw images undergo pre-processing like resizing, normalization, contrast enhancement, noise removal, various. And that after pre-processing, the data set is split into three sets: training set, validation set, and testing set. Next comes model selection. We have the project selects YOLO V8 for
Yes,
real.
Archana,
Sir,
what is the input for this project, Amma? What is the input and what is the output you are going to get?
images, sir. First, the coffee leaves images were provided as input, and after processing, the output we get is we get a highlighted box around the disease output in the output.
What is the scalability?
So scalable depending upon the data set, like size of the data set. The model also increases its the highlighting boxes size of the highlighting boxes, and improves based on the images taken, sir.
Okay.
What are the various, you said various augmentation technique you have used. What are the various augmentation technique you have used in your implementation?
Augmentation like resizing, contrast enhancement, and noise removal.
How you have done this?
Sorry, ma'am.
You are manually done this or with the support of any tools?
I'm not sure, ma'am. Actually, from the existing data set we have.
Okay, what is the difference between precision and recall?
Precision means like how precise the disease is detected, and recall means whether if we give one image to the model, and if we repeat the same model, whether the results obtained are same or not.
Which loss function you have used?
Loss function. Not sure, ma'am.
Okay.
Okay, Amma.
Okay, thank you.
Okay. Thank you.
Okay, Archana, are you willing to present your paper in the journal?
We'll let you know.
Yeah, okay, Archana, thank you. Now, next I would like to call K. Anusha, paper ID 230 from Guru Nanak Institution to present their paper. Anusha. Anusha, are you there? Okay. Okay, next moving forward, I would like to call Meghana, paper ID 236 from Guru Nanak Institutions to present their paper.
Okay.
Yeah, Meghana. Over to you.
Good afternoon, sir. Good afternoon, ma'am. Our project title is on a secure data dynamic search with symmetric encryption, strong security, and my teammate are Bharat Chandra. Abstract is this project introduced a secure and fast method to search encrypted data stored in the cloud. It uses dynamic searchable symmetric encryption and bitmap indexing to allow users to search encrypted data without revealing any data. Only authorized users will, with permission from a cloud service provider, can access the data. This system provides security and search speed, making it suitable for large cloud storage environments. In existing system, we have proposed a DSSE system. The client sends encrypted data with keyword indexes to the server. The server platforms keyword searches using encrypted trapdoors, updates and searches may leak some information to attackers. Drawbacks of the existing system is no stronger security authentication, cannot guarantee full data security, potential for data leakages during search updates. We have proposed SRDSSEA and SRDSSEB with SHA 256 and bitmap indexing. It uses encrypted bitmap values to represent file identifiers, and CSP handles user key approvals, adding extra security. The server only processes queries if the user has valid authorization. And the advantages of this proposed system is stronger authentication mechanism, better security for stored data, and efficient and faster keyword searches. And from here, my teammate Bharachandra will continue.
Yes, Bharat Chandra.
Good afternoon, sir. Myself, I am Bharat Chandra. So now I'm going to tell about the architecture of our system. The main system tells about the project with the secure methods of using the encryption data stored in the cloud, which are used by DSEE, dynamic searchable symmetric encryption. So without the revealing the data, no one can authorize our system architecture to access this data. This system secured set the speed, making suitable large cloud storage. And the main development of the resource of the cloud data storage with the system with the use of DSE, uh, with the help of ensuring the encryption data while protecting our attackers or the leakages. Mainly allows the DSS encryption data to update and the researchable securities cloud environment. Main existing the DJ updates. This project uses the forward backward. The mainly purpose when the project stores even the type 1 and type 2, these leakage are the critical to relevant the encryption files to keeping the secure life.
Yes, Bharat Chandra.
Sir.
So what is this FB and SR in DSSC?
Sir?
FB and SR. FB DSSE is there, no? What is that SR? And SR and SR DSSE and E and AB is there. What is that?
CSP. Sir, tell me. The data of CSP.
FB hyphen DSSE.
Cloud service
Forward
provider.
and backward.
CSP.
Yes. What is the use of that?
The data.
Okay. Madam Kala ma'am?
Yes, sir. Yes, sir. Have you simulated this model? Have you implemented?
Yes, ma'am.
Okay, which tool you have used? Yes, this is the implementation. Okay, how you are testing your model? How you are testing your model? You are saying it is working better than the existing one, right? How you are making sure that one?
Algorithm, ma'am. SHA-256.
Yes, I'm also accepting that one. You are used to that one. You are saying it is more secure, right? How you are analyzing existing models are there and
Ma'am, based on SHA-256 with the secure hashing, password and keys, ma'am.
How you are measuring that one? If I am saying one student is performing better than the other student, based on some rubrics will be there, right? Maybe marks, maybe their performance, right? So some criteria must be there. If it is a research, it must be depends on values.
It protects sensitive data.
How? Some value evaluation metrics must be there.
With the help of the key security and features, ma'am.
Okay, leave it is. Find it, okay? Don't answer for the sake of answering. Okay. Search it. Whatever we are saying, we need proof in research. Okay.
Okay.
That's all.
Thank you, Meghana and Bharat Chandra. Thank you, Amma.
Okay.
Thank you, Meghana. Would you like to post your research paper on journal?
We will let you know.
Okay. Next, I would like to invite Satvika to present the paper holding ID 270 from Guru Nanak Institution's Technical Campus. Over to you, Satvika. Satvika, are you there?
He's not there.
Next, I would like to invite Ramakrishna to present the paper holding on ID 271 from Guru Nanak Institution's Technical Campus. Over to you, Ramakrishna.
Good afternoon, everyone. My name is Ruchita. He is my teammate. He is not available, so that I am taking it.
Okay, Ruchita, continue.
Is my screen is visible? Hello.
Yes, yes. Yes, yes. It is visible.
Good afternoon, everyone. My name is Ruchita. Now I am here to present my project. Title is an enhanced fake news detection system using Fuzzy deep learning. I'm here to give overview of this abstract objective introduction, literature survey, existing proposed system architecture, system modules, and requirements, etc. Abstract. Fake news spreads quickly in online and creates a confusion. Normal detection methods cannot handle confusion and unclear language. So we
Ruchita,
used
on your
logic.
video on. Yes.
Is
Yes.
it okay, sir?
Yes. Yes. Now continue.
So we introduce our system with physiologic and deep learning to give better accuracy results. Our main aim of this project is to detect fake news more accurately. In this, we used our existing database system called LIAR2, and we used with the model FDHN Fuzzy Deep Hybrid Network to get the accurate results. Fake news look like real, but spreads lies. It's common on social media. Deep learning is good, but it can be confused by unclear language. So we introduced Fuzzy Logic helps the model deal with uncertainty better. We have many models like RNN, LSTM, but have been used for fake news detection. But they can be hard to understand. Fuzzy logic can help in areas like sentimental analysis and medical diagnosis. In existing system, we used CNN with bidirectional long short-term memory networks. So what are the drawbacks of it means it cannot explain the decisions betterly, and they only say real or fake. It cannot give explanation why it is real, why it is fake. So we introduced a new system in proposed system called Fuzzy Logic with deep learning. In this we used NLP, where it is a part of artificial intelligence that focus on interaction between the human and computer through natural language. And it uses BERT for better word understanding, because but means bidirectional encoder representation from transformers, where it can read from both ends, from left to right and right to left. It can read it and understand what the actual meaning of this. It has the power, but has the power to understand what actually we are saying. In this architecture, we give textual context to the model, and then we get the result like fake or real. In system modules, first of all, here we use LAIR2 data set, and we first of all we need to clean it through using natural language pre-processing, and then we convert into, as we are passing text, so our machine cannot understand, so we must perform embeddings, which means converting textual information into numerical data, and then we give our trained data to our model LSTM, long short term memory. Then we train the model, and then we get classification, like we have both classifiers like real and fake. Based on the information, our model will predict it is fake, it is real. And we here are some use case diagram and class diagram, activity diagram. And the future enhancements, here we can only pass the text. If you we can also add some future enhancements like sending images and video analysis, and also you can use advanced models like ChatGPT, etc. This is our system requirements.
Yes, Ruchita, are you
Sir.
using any mathematical formula for converting text to numerical data?
Yes, sir. I'm not sure, but we use a model called BERT to transfer textual data into numerical data, where it understands it reads from left to right, and also it reads from right to left, so it can understand. Like example, if we have example like a dog chases cat, and another example, cat chases dog. Here both sentences give different meaning. As we go with bag of words, it just count the words and predict that they both are equal. But whereas it reads from left to right and understands that both are different.
Okay. Okay.
Okay, nothing is there. All the best.
Thank you, ma'am.
Okay, thank you, Ruchita. Now, next I would like to call Santosh Kumar, holding paper ID 272, to present their paper.
Yeah, give me a minute.
Santosh Kumar.
Yeah, is it visible?
Yeah, it is visible.
My friend Lal will start the session.
Good evening. I am Gajanlal Malawat. We are of a team of 3 members, Santosh, Likita, and Mimim from Guru Nanak Institutions. Our title is how do crowd users express their opinion against software applications in social media, under the guidance of Mr. Sunita Mem. Santu abstract. Overview is objective, abstract, objective, instruction, and literature survey 2, exiting system and proposal system, and system architecture, system modules, execution screenshots, and future enhancement conclusions. In this project, we focus on analyzing feedback shared by users on social media platforms. We classify emotions into 5 categories: angry, sad, fear, surprise, and happy. To to do this, we use hybrid deep learning algorithm models and combined breadtime LSTM, and bread provides deep conceptual understanding, while LSTM captures the sequential nature of emotions. This approach helps developers identify emotional charged uses in feedbacks and supports better decision making. Our model achieved 92% accuracy, um, outperforming traditional machine learning models like Navy Bayes and logistic regressions and random forest and MLP. Our our project objective is to design and implement a hybrid model that integrates the strength of BERT and LSTM to classify users' emotions from social media feedbacks. We aim to move beyond simple positive or negative statements, analyze and instead identify specific emotions. We also want to uh, perform traditional models in accuracy and help software teams make more emotional, informed decisions for bug fixing
Mr.
and future improvement.
Mr. Gajanal, on your video here.
So, okay. Actually, it was not on, sir.
Huh?
Sir, it's okay. Sir, uh, user feedback plays a vital role in enhancing software quality. However, most of these feedbacks instructions and emotionally which makes it difficult to analyze. Traditional statements often miss this depth. Sorry. To overcome these problems, we use advanced natural language processing techniques. By combining BERT and LSTM, we decode emotional tones and turn raw feedbacks into usable insights. This helps system prioritize key issues and improve user satisfaction. Literature survey.
Is existing system and proposed system.
So existing
What is
system.
the drawback of existing system?
Sir, memory consumption and sensitivity noise.
How you are overcoming in proposed system that?
Sir, proposed system.
So in proposed system may uses two deep learning models, that is BERT and SLTM, and these two understand the meaning of word by looking at the full sentence. For example, the word bud could means an insert or a software error depending on the context. And LSTM then captures the how emotion involved across the sentence. For example, if a word starts with happy but ends with frustration, LSTM helps detect that transitions. This combines leads to better understanding of feedback and emotions in proposed systems.
What is that BERT, BERT full form?
Bidirectional encoder representation from transformation.
What is the use of that?
Sir, it understands the meaning of word by looking the full sentence, sir. Means
okay.
How BERT is better than LSTM?
Ma'am, it captures the
both
semantic meaning.
Both have their individual things, ma'am. BERT is used as a thing which divides the sentence into certain vectors and based on their meaning, and it can read the data in the both directions. First, it divides the data, then in the LSTM, it predicts the emotion, ma'am. Based on the prediction, we get the output, ma'am.
LSTM also bidirectional LSTM, is it?
No, ma'am. No, ma'am. It is long, short term, ma'am.
Long,
Long,
short
short
term.
term.
Bidirectional LSTM is existing.
Sorry, ma'am.
LSTM basic is there. Bidirectional LSTM is there.
Okay, ma'am.
Okay, that's it. Thank you.
Thank you.
Thank you.
Okay. Thank you, Gajanlal. Thank you.
Thank you.
Thank you. Next, I would like to call Prajot Singh, paper ID 273, to present their paper. I guess he is not present. So, moving forward, next I would like to call upon Sri Charan Gaud, paper ID 274, to present their paper. Sri Charan Gaud, are you there?
Good afternoon, sir. Good afternoon, ma'am. Am I audible?
Yes, audible.
1 minute, so let me present. I am B. Siddhartha Reddy, and my teammates are A. Vamshi Krishna Reddy and B. Suchirangao. We did this project under the guidance of Mr. K. Shankar, sir, Assistant Professor CSC. Our project is deep learning algorithm for cyberbullying detection in social media platforms. Coming to abstract, our project is about detecting cyberbullying automatically using deep learning. We use AI for it. There is no need of human interferences. We use special features like emotions, sentiment, and text analysis to improve the accuracy. We tested different models and found that the word CNN with transfer learning gave the best results, where we got the 97.7% of accuracy. Coming to objective, it is a smart system that detects cyberbullying from social media posts. We use advanced techniques like word CNN and real-time weather for finding the bad comments. As we can see, there are many bad comments have been used in the comments in the social media. By using the AI, we can detect them. The AI can understand many languages. It can transfer the language, can understand and detect and delete the comments from the social media posts. Coming to introduction, cyberbullying is growing with social media use. Like traditional ways like blocking and reporting have become very slow. In that case, the AI can helpful. It detects so much fast and it has so much accuracy, and it can delete the comment from there itself. We use AI to automatically detect harmful message using text and emotional analysis. Our model works fast and it is very accurate. And my team at teacher will continue.
Good afternoon, everyone. Coming to our existing system, we used an algorithm called ML classify with feature density. This existing system uses traditional machine learning method to detect cyberbullying. In this method, it relies on basic features like keyword extraction and sentiment analysis. For suppose there is a word called stupid, this model classifies that stupid word as harmful message, and if that word is in a sentence, if for sometimes if the in a sentence meaning will be changed. Meaning will be changed. To overcome this problem, we used our model. We trained our model using word level CNN. The system, this model recognizes cyberbullying by understanding tone of the sentence and meaning of the meaning of the sentence, and yeah, compared to exist system, we overcome problems like computational cost is decreased, and we can use it in real time, and system architecture will be continued by Vamshi.
Good morning, everyone. Just a minute. Okay, the system starts by collecting text data from social media platforms. Then the data is sent to data cleaning and tokenization. Here the unimportant data is removed, and the data is breakdown into individual words using a method called tokenizer. Next, clean data is converted into suitable format for the model. In next step, feature extraction and selection. Important features such as sentiment and emotions are extracted from the text.
Vamshi, on your video.
Sir.
Yes, yes.
Okay, next step is the learning model for cyberbullying detection. These features are sent to deep learning model like word CNN. Here the model is trained to identify non-bully and bully words. Then the decision is made. Okay, next. Okay, the system models are data set. In this, we use CSV file with 47,000 labeled data. Types are gender, religion, racism, etc. And the next module is importing the necessary libraries. Python libraries like pandas, numpy, keras, and etc. are used, and data pre-processing, cleaning. Here the data is cleaned, and missile values are removed. Next, model creation for word CNN. Used word CNN with 128 filters and softmax layer to classify 6 types of cyberbullying. Next, training and evaluation. Our system achieved 97% of accuracy on the test set, and the saving the training model. Here the model is saved in a .h5 format. Thank you. Next, Siddharth will continue. Okay. Sorry. Login page. These are login page. Here we should enter username and password. Next, we should upload the CSV file. And here we should give the sentence, or it takes inputs from social media platforms, and then the sentence is classified into non-cyberbullying or cyberbullying. Okay, that's it. Thank you.
Coming to future enhancements, it detects the roles like bully, victim, or bystander. It understands the full conversations. It works in the multiple languages on mobile, and it can work also on mobile, and integrate with social media for live alerts. Coming to conclusion, deep learning is better than manual methods because it is fast and it can detect more fastly than it is more fast compared to the manual methods. Word CNN with transfer learning gives high accuracy. I also mentioned it has 97.7 accuracy for a project. Our system is ready for the real world use. Thank you.
So, what is the deep learning method we are using in there? What is the deep learning algorithm we are using?
So we use word CNN model.
Word CNN.
Which one?
Which one?
Word CNN.
Word CNN.
Yes, sir. Yes, ma'am.
WORD.
Yes, ma'am.
Such a model is there?
Yes, ma'am. It comes under CNN only. It used to classify data, ma'am.
All CNN models we can use for classifying the data, but word CNN, I don't know what kind of CNN it is. Okay,
ma'am, we normally use CNN on visual data.
What is your input? Is it a text or image?
everyone. Myself Pavitra. I'm going to explain about the system architecture. So here we can see the input data. The architecture starts with an X-ray image. It is a chest image representing a medical image application. The input data has dimension denoted as a D into H by P into W by P, where D stands for the depth of number of channels and H by P stands for height divided by a path size, and W by P stands for width divided by the path size, and next the path embedded. So these images is divided into the patches like small sub regions of the image. So each path in embedded into vector representation enable the model to process the images as a sequence path and either flexible. And dual activation. This dual activation will be helps in the model to learn the complex relation in any data. And again, we can see a batch form. In this batch form, the output of dual activation is normalized into, and this is helped to stabilize the training by normalization means various across the batches. And next we can see the depth-wise convention. So again here the process is repeated like dual and batch form. This fully is called as a result dual connection. And after that we can see a point-wise conventional. Again the process is repeated dual and batch form. This total process is called as an uh, conventional mixture layer. And the last two processes are global average pulling. So this will be, and next the fully connected. So
Uh,
this fully will be.
Pavitra, using that formula, what you are going to get?
So here we taken the example as a chest, sir. So here we can dimension the width and the height of and that X-ray like grayscale one.
Mm.
Yeah, using that we can measure the by this formula, sir. D into H by P, like height and width of this depth. We can
Okay.
measure the, yeah, yes.
What is this GLU? GELU?
GLO is just a minute.
Ma'am, it's a Gaussian error linear
Gaussian
unit, ma'am.
error
Like
linear unit.
What is its
Activation
function?
function.
Why you have gone for GELU? Normally everyone will use RELU, RELU, right? Why you
Yes, ma'am.
specifically choose GELU? Is there any advancements is there?
Because it helps the model to learn complex relation in the data.
What is an activation function?
Activation activation function.
Ma'am, it is used to process the image. Like we
What
add
happened?
weights and bias to the image for every pixel, and this activation function used to normalize the using weights and functions. It helps to analyze the image like every pixel in an image, ma'am.
Then why GELU?
Ma'am, as it's
In the activation
used,
place we have.
Activation, many activation functions are there. Normally, along with the CNN, we will use a ReLU, leaky ReLU.
But this model
Many
is
is
a
there.
complex relation. For that we have taken this dual model, activation model. Yes.
Have you tested with ReLU? It is not working well.
no, ma'am, actually it's a proposed system. We actually used in existing system we used ReLU, and using ReLU it is basically used to reduce the time complexity. And for ReLU we can train use for training the model. We can using ReLU it trains the entire data set at a single time, and using spatial and channel wise operations it performs.
And this is not the answer. Okay, what is a
Okay,
which
okay.
block? Okay, that's all. Thank you.
Okay, Pavitra, thank you.
Thank you, sir.
Thank you, Pavitra. Siddhartha, would you like to post your research paper in journal? Siddhartha?
Let me message you. Give me a time.
Okay, thank you. Next, I would like to invite Aditi to present the paper holding ID 276 from Guru Nanak Institution's Technical Campus. Over to you, Aditi.
Yeah. Good afternoon all. I'm Aditi from Guru Nanak Institutions from 4th year CSC 1. So I'll be just sharing my screen. Just a second. Is my screen visible?
Yes, visible.
Yes. Yes, sir. So good afternoon all. I'm Aditi Pilankar, and today I'm going to present my paper, the title Efficient Anomaly Detection Algorithm for Heart Sound Signal. So my co-authors are Sai Charan. He's not available today due to family emergency, and we have done this project under the guidance of Dr. Geeta Tripathi ma'am. So coming to the project and the paper, so as we all are aware that cardiovascular diseases are actually remaining a leading cause of death worldwide. So over the period, we have seen multiple technologies and algorithms that have been people have been implementing so that these cardiovascular diseases can be identified in early stages so that they can take some precautions for it. So my project is based on that cause, and in this project I have implemented deep neural network, which is little better and has been tested better compared to other traditional methods. So we tested this algorithm on a physio.net dataset, which is a dataset which was made in 2016. So it has a huge set of heart rate sound waves. So instead of pictures in this project, and we are using heart sound waves. So this physio.net and sciencey dataset had huge set of sound waves with classified as abnormal and normal sound waves. So when we tested our model on this, we successfully achieved 99% accuracy and 89.9% sensitivity and 98.5% specificity. So through this we could this actually came out as a good promising tool for early detection of cardiovascular diagnosis. So the whole objective of this project and the paper was to develop an AI driven approach, since AI is in market. So to implement such approach so that we can implement in our day to day situations in our health sector too, and to detect the heart anomalies from phonocardiograms. So as I meant,
Tell me
yes,
the drawback of existing system.
sure. So existing system that was used before and on which I created the proposed system was a Swin transformer model. So since Swin transformer model is also a part of deep learning model, so previously we used to use this to know the anomalies in heart sound signals. So the drawbacks that happened is, so in Swin transformer model we had multiple layers, sorry, we had multiple stages instead of layers. So in these stages the whole data set would be divided into different patches, which as mentioned that there are different stages including patch embedding, linear embedding, and self attention calculations, which means the process means that when the whole data set was divided into different patches and each patch means different set of data set was being studied and then coming to the conclusion. So if the data is huge, the system was taking a lot of time to process it. And in the self attention calculations, which means that actually checking which is an important signal or not. So as it couldn't handle huge data set of taking a lot of time, we are also aware that the heart signals are very sensitive. So due to these reasons, we were not getting a good percentage of accuracy, which led us to go and research on new technologies such as deep neural networks that I have done we are doing the project on. So proposed system, we have implemented deep neural network, and in this neural network we have implemented CNN networks as a subset, where we have, so this is the system architecture of the proposed system. So when we give the heart rate data set to the system, it pre-processes and we do feature selections. So in this stage, all the layers of the deep neural network comes in, and later when the data is filtered, the data gets trained to check which is a normal heart wave signal and which is an abnormal heart rate signal, and thus by the trained data it will detect whether it is normal or not. So the system model includes, one is the importing data, that we import data from the physio.net dataset. We retrieve the information, and we we do split the data in this, but in a 80 and 20 ratio. And then we implement the training model, and we build a model, and we implement and we test the accuracy. So coming to the data set, at the beginning we use dot wave audio files. As I mentioned earlier, this is a heart sound signal, so we use audio files. So this has a mix of normal and in abnormal cases of heart rates. So next is importing necessary libraries. We are the for implementing of deep neural network, we use various libraries. we use care we
Yes,
use keras. Yes
Aditi,
sir. Yes sir.
what is meant by non-invasive approach in that PCC offer? No? What is that non-invasive approach?
uh Sorry sir.
Non-invasive approach.
So it
Yes.
mean
Yes.
Yes
Could you,
sir.
what is that?
So no, as per my knowledge, so non-invasive approach means that since the heart sound signals are imbalanced and the heart murmur sounds are very sensitive, so in this project, non-invasive method means which is how we tackle the imbalanced data.
Okay.
Yes.
What are the various feature selection technique you have used? Not various, which feature selection method you have used?
Sorry, ma'am. Feature selection in terms of implementing or in terms of fit.
Implementing. You said, show me the diagram. Pre-processing and feature selection is your first step, right?
Yes,
From
sir.
the
Yes,
data set.
ma'am.
Which methods you have used for that one?
Ma'am, for feature selection is when we filter the data and which when we bring out what is the important heart signals. So we use max pooling 2D layer, and
Max
yeah.
pooling is coming under deep learning model architecture, CNN architecture, right?
Yes, ma'am. Those layers are implemented in under this so that we can filter out what are the important signals.
My question is, as in this diagram, in data set, first step is data set is there. It is going through pre-processing and feature selection. Then only it is going to deep learning model. So here, before entering into the deep learning model, how you are doing feature selection?
Sorry, ma'am, I'm not sure about it because as a whole process, it was regarding the different layers of deep neural network.
That is only this sender part is coming as CNN.
Yes.
Yes. Before? Okay, it's okay. Thank you.
Okay, ma Aditi. Thank you.
Yes.
Thank you, Aditi. Would you like to post your research paper on journal?
Yeah, sure.
Okay, thank you. Next, I would like to invite Prashant to present the paper holding ID 277 from Guru Nanak Institution's Technical Campus. Over to you, Prashant.
Good afternoon, everyone. This is Prashant. So,
Prashant, video.
Sir,
Yes, start.
sir is visible.
Yes, yes.
Okay. Thank you for all. Today my project is efficiency of data partition strategies techniques for using the cloud computing. So main goal of this project is, yeah, sorry for disturbance. These are the overview of the project. What they are the important points are we have conducted in the PPT. So coming to the my abstraction. So most of the cloud computing using to the storage purpose for using the remote local area controlling. So most of the companies we are looking for the how the data will be storing in the security manner. So my project is giving to the security and efficiency of the data storage towards to the cloud database. So in this abstract, so giving the in the location of remote control area in the hardware and software, we can giving to improve the efficiency and security of our data in the data manner. So the object, the our teammate Deepika will be explain the objective and introductions.
Good
So over
afternoon,
to Deepika.
everyone. Objective. The study explores scalable data partitioning techniques in cloud environment to efficient manage large volume of data. Managing the big data in the cloud challenges like scalability, load balancing, and processing speed. The main goal is to analyze and compare the data partitioning strategies. Introduction. The big data demands optimal and scalable data processing techniques. Cloud computing has data management with flexible and adaptable algorithms. In cloud, utilizes cloud computing efficient to manage and analyze data sets. Cloud service providers such as Amazon Web Services, Microsoft Azure, and Google Cloud Platform.
What is the
Data
drawback of existing system, Amma? What is the drawback of existing system, and how we are overcoming that?
The drawback of existing system means they are the how to the secure data will be a loss, sir. So that's why we can using that existing system too. We can use the proposal with the secure of how to secure the data in the particular manner. So we can using to the two types of keys. So first key will be there. 1 minute. So this type of security key will be encrypted our data and decrypted the data. For example, for our employee will be log in our the website and checking the our particular data. So they can access the only for the data. No another 30 persons will be not uh, using to secure our data. So this way we can using the encryption and decryption methods for using the keys. So first of all, we are using the like the hash functions keywords. So our data will be generated in the types of distributing parting techniques. So our large amount of data will be separated into the small parts of data. So they're using the some small parts to giving the key IDs. So key IDs will be to initializing the our particular key to generating the particular data. So this the main goal. And
What
this
is
is of the
hash,
UML data.
what is hash function?
Sir, hash function is giving the particular hash key to giving the particular value. If we can giving the hash key, then we can generate the particular key in the what type of the data will be available in the particular database. So they will be secure and giving to the users.
Okay.
So
Which
this is
hash
the sequence.
which hash function you have used?
Generally, we can use for key and search dictionary hash function.
Okay.
Yeah, ma'am. This is our snapshots for our website. So first of all, we can any one company we can to give the any employee for giving the registration first. So we can registration first, then will be authorized person or not for giving the cloud bases unit, admin unit. So these are the cloud service. So what are the cloud service are available in this particular? These are the cloud who are the cloud based to working the particular employees. They will be logging in the particular page. This is the admin page. So we can enter the our admin page. We can seeing the this type of page. So uploading the our data, like our data will be generating one key. So file key are there and encrypted data will be there. For example, we can give the PDF files. So we can that PDF file will be encrypted. So when we can use the particular key generated, the key generator will be generating like, for example, this file file ID and key. So when the key is giving to the particular approval, the cloud basis, then only we can decrypt our data and read the particular data. That's it.
Okay, Prashant. Thank you.
Yes, sir.
Okay.
Thank you so much. Thank you, ma'am.
Prashant,
Yeah.
would you like to post your research paper on?
Yeah, sure. Okay, thank you.
Okay, thank you, Prashant. Okay, thank you everyone. Thank you one and all. I would like to extend my heartfelt thanks to all the participants for their extraordinary efforts. And now I would like to call our external chair, Dr. Kala KU, for the feedback.
First of all, thank you everyone for inviting me as a session chair in this conference, especially Dr. Geeta Tripathi ma'am. I was also a part of Guru Nanak Institute's 1 year back. Thank you so much. And almost every presentation, especially AI related presentations, are good enough, but as a first stage, because of almost everyone was students. So it is a good attempt, but I'm expecting everyone to be involved more in each and every concepts. But don't blindly execute any AI model. Try to move more in deep. That is my suggestion to the students. Okay, thank you everyone. That's all from my side. Thank you.
Thank you, ma'am. Thank you for
Thank you.
your
Thank you.
feedback. Next, I would like to call upon Mr. Sirajul for vote of thanks and to display the appreciation letter. Sirajul sir, sir, are you there?
Sirajul sir.
Devi. Let's wait. Before that, I request all the participants to fill the feedback form which is sent in the chat. If anyone are interested to give a verbal feedback, then please do feel free to share their thoughts.
Small announcement, sir. We have one more research paper. I'd like to invite Rajendra to present the paper holding ID 305 from
Yes,
Nanak Institution's
good
Technical
afternoon,
Campus.
everyone.
Over to you, Rajendra.
Wait. Good afternoon, everyone. Today, my topic is about Talk Tech Advanced NLP chatbots for smarter campus interaction. Am I audible? Hello. Hello.
Yes,
Yes, you are
audible,
audible.
audible, audible. Start.
Yes. We are team of 3 members. My name is Rajendra Reddy and Sadvika Reddy, Kalyan. I'm going to present the overview of the presentation is abstract introduction or literature survey, existing system, proposed system architecture, hardware and software requirements, future work and conclusion. Here, the project is about the chatbot using in the university for the students who have completed the 12 plus. They're struggling to join the college after the inter. So by using the chatbots, they can easily can they can get a way to join in the in the universities. Here we are using the in the in the project we are using
Ma,
tokenization, utilization, and
what is the what is the drawback of existing system? Tell me first.
in existing system it is low flexibility, less accurate, and limited scalability and pure context. In the existing system we are using the term frequency and identity frequency, so that the system cannot understand word meaning or context.
Hmm. Then how we are getting that accessibility or a high frequency in that in proposal
By
system?
by using the neural networks, by using the natural language toolkits. By in that we are using tokenization, limitization, and noise removal. Tokenization, it can takes the inputs as the it divides the sentences or words as a characters, and it takes into the frames. And the file which deals with this chatbot is intents.json. Here the proposed system advantages are high accuracy, it can achieve up to 99%, like and also advanced NLPs tokenization, limitization, semantic analysis. And there will be a optimized performance by using the feed forward neural network. In the system architecture, we have to develop the chatbot, we have to initialize the plan, and in after that we are creating the JSON file. After we have to pre-process the JSON file, and we need to make it as the file. And later the decision it continues or stops. If it stops, then feedback
improvement the
Yes,
student has
how
to.
we are converting that using a bag of words to some numerical data?
Yes, sir. By using the bag of words, we are converting the text into the numerical data.
How you are converting? What is that? What is the use of that? How you
What
are
is
converting that text to numerical? Is there
like?
any formula for that?
Yes, like if you take some a chartboard, like if you take that, like we have to give 1 or 0 coding, then we can convert it easily.
Okay. Ma'am, Kala ma'am, any questions, ma'am?
Like here are the snapshots of the like execution.
You are saying 99% accuracy you have achieved.
Yes.
Is it really?
Like what we did up to now, like not integrated in the university, but what we did is like up to that.
Okay. Okay, that's all. Thank you.
Thank you, ma'am.
Thank you, Rajendra.
Thank you, Raj.
Thank you.
Thank
Thank
you,
you.
Rajendra. Would you like to publish your research paper in journal?
I will let you know.
Okay. Next, I would like to call Sirajul sir for a vote of thanks and display appreciation letter.
Thank you, ma'am. Am I audible?
Yes, yes.
So, good evening, everyone. I am MD Sirajul Haq, Assistant Professor in Computer Science and Engineering. As we have come to the close of this enriching national conference on futuristic technology, I extend my heartfelt gratitude to each one of you who made this event a grand success. A special thanks to our esteemed session chair, Dr. Kala K.U. ma'am, and our internal chair, Mr. B. Lalu sir, for guiding the proceedings with such grace and insight. To all the paper presenters and delegates, your contributions and innovative ideas have truly elevated and discussions and inspired us all. We are deeply grateful to our institutional leadership, the organizing committee, sponsors, and dedicated volunteers who behind the scenes efforts ensured everything ran seamlessly. Let us view this movement not as a conclusion, but as the beginning of the new collaborations, continuing learning, and shared a commitment to shaping the technological future. Thank you all once again.
Okay. Thank you,
Thank
sir.
you, sir.
Thank you so much, everyone.
Thank you, Madam
Thank you,
Kala,
sir.
Madam Lakshmi.
Thank you.
Thank you, everyone.